Welcome to the north shore of Mono Lake. So here's the lake here. You can see the peaks of the Sierras off in the distance. And we're now looking east. And off this way, you can see there's this unassuming flat-topped hill. And to the right, it's sort of a dark color. That point there into the lake is called Black Point. And it's actually, despite its unassuming appearance, it's actually rather special because it's actually an undersea volcano, or an underwater volcano, I should say. And we don't get many chances to see underwater volcanoes on land, but in this case, Mono Lake, which you can just see off there on the horizon, used to be a lot deeper back during the various ice ages we've had. And so this Black Point volcano actually erupted during the last ice age, and it was underwater at that time. And its overall form is very flat top because, well, first of all, anytime you have eruption underwater, it's very common for it to be very explosive, due to whenever you have water and magma mix, it tends to make the water flash to steam. The lava and the water mix in a sort of continuous stream to make sort of a, I don't know, more like a rocket exhaust sort of plume of ash that's spewed up in the air, in often a very violent way. And in the course of that process, the lava is broken into tiny little fragments typically. Those are carried around by waves and make this big flat shape. But basically the top of that hill was basically the level of the lake level when it was erupting. So this brown stuff is basaltic ash. If we look in here, we'll see a sedimentary structure called climbing ripples, where there's these ripples that climb up on top of one another. And those always indicate very rapid deposition of sediment. So in this case, as the volcano was erupting, it was producing a lot of this basaltic ash sediment that was then being swept along by currents in the lake and piling up very rapidly, creating these climbing ripples. Now, the other thing you get when you have rapid deposition of sediment, it's hard for the water to escape quickly. And so the sediment tends to be very saturated with water. So if you have any sort of shaking, like say from an earthquake, then that sediment will basically liquefy and you'll get soft sediment deformation. So all the folding in here of the overall structure in here is actually related to soft sediment deformation. Probably, almost certainly due to an earthquake. Again, every time you have a volcano erupt, there's almost always lots of little earthquakes as the magma is pushing its way around through the ground. Because this was made of rapidly deposited, unconsolidated basaltic ash, at some point in its history it began to spread apart at the top. And there's some interesting fissures that have opened up due to the spreading of the unstable pile of sand. Okay, we're now approaching the fissured area. Whew, that goes down pretty deep. Okay, let's see if we can get into this giant fissure. Probably this is some sort of a tufa. Presumably at some point since this fissure opened up, the lake level came up and drowned this fissure, and then the tufa was deposited while this was under the lake level, would be my guess. And now it's weathered through in places, and the basaltic tuff weathers more rapidly than the calcite tufa. So you get all these weird little windows and pockets. Okay, this looks exciting. I wonder if I can get out over here. Or if I can squeeze through that little hole. Oh wait, there might be actually a squeeze hole over here that's slightly bigger. Slightly being the key thing. I gotta take off my backpack for this one. So you can hear that scraping noise, that's me scraping against the walls. Here you can turn around to selfie mode here. Okay, got through that.